Good morning, it's Engineer Heather there. I warmly welcome all of you guys on my channel Complex World. So today we are going to learn about the latch circuit, which is the most important circuit in the digital electronics. So the subject is digital electronics, which is the second part of my video. The first part was the logic gates. In the first part I have only explained the digital logic gates. So this is the lecture number 2 of digital logic design and digital electronics. So we are going to start the topic from the second topic of our digital logic design, which is the SR latch using NAND gate. So here you can see the circuit, which is a circuit of a SR latch. Latch is one of the most important topic in the digital electronics. Whenever we talk about the sequential circuits, latches are most important topic. So let's start the circuit SR latch using NAND gate. Okay, after the latch, we move on the flip-flop circuits and the counter circuit, but latch is the basic building block of digital electronics. So let's start our today's lecture, which is SR latch using NAND gate. So you can see in a circuit that we have two NAND gates here, and you must have to remember one property of a NAND gate, that if any one of the input is 0, NAND gate give us the 1. You can see on truth table 0 1 1 0 1 1, and we have NAND gate A dot B complement. So you can see on 00 we'll get 1 1 1 and 0. So if any of the input is 0, then NAND gate give us 1. So this is the most important property of a NAND gate. So remember this property of a NAND gate when you are going to implement the SR latch circuit by using the NAND gate. So by using that property of a NAND gate, we can see if any of the input is 0, the output will be 1. So we don't have concern with the second input if any of our input is 0. Okay, so the latch circuit by using the NAND gate consists of two inputs, which is S and R, and in output we have the Q and the Q bar, which is the Q and the Q complement. The first output is the Q and the second one is the Q complement, and you can see this Q output is going as an input to the second NAND gate, and this Q complement is going as an input to the first NAND gate. So we have four terms here: SR, which are the two inputs to the NAND gate, and Q and Q complements are two output, which are going to be the inputs of these two NAND gates in this circuit. So remember this property and implement the table one by one by giving the inputs. Okay, so how to construct the truth table for this SR latch by using the NAND gate? We have two inputs S and R. So we have S here and R here, and for output we will write Q into N plus 1. 0 0 0 1 1 0 and 1 1. Okay, in the output we have Q into N plus 1, and remember this, that in the sequential circuit the output depend upon two things. This is our state. In the sequential circuit the output depend upon two things. The first one is what input is given to the system. In the first thing, and with the sequential circuit depend upon input given, and the second one is the past output. Okay, let's start the implementation of this truth table on this latch circuit by giving the input as S and R to the system and get the result Q and Q complement. We will start from this one 1 and 0, or we can start from this one 0 and 1. I will explain later that why I am not starting from 0 0 and 1 1. Okay, so let's say I am taking this as an input Q 0 and 1, as the value of the S is 0 and the value of R is 1. So when I am taking that value for an input 0 and 1, what will be our output for this Q and Q complement? As in my previous videos in a digital electronics, I have clear each and everything about the NAND gate, that when in the NAND gate, whenever the output is 0, any of the output is 0, any of the input is 0, the output will be 1. In my previous, you can see my previous video on logical gates. So when any of the input is 0, the output will be 1. Okay, by using that NAND property, if any of the input is 0, the output will be 1. so we have no concern with what will be our second input. So we have S0 here. If any of the input is 1, so we will get the if any of the input is 0, we will get 1 in the output. So we have 0 here. What will be the output of this queue? We will get 1. We will get 1. So this one will come to the second input of the second NAND gate. So this will become 1. So 1 and 1 in NAND gate, 1 and 1 you will get 0. So we have here 0 and 1, 0. You can see the value of the q is 1 and the value of the q complement is 0. It is clear from the equation that the complement of the 1 is always 0. So the state is proved for the SR latch, that the value of, if the value of the S is 0 and the R is 1, the output will be 0 in SR latch by using the NAND gate. Okay, same is the case with that input 1 and 0. When I am giving 1 as an S and 0 as an R, so you can see we have 0 here. So whenever we get 0, we have no concern with the second input of a system. So whenever there is 0 in a NAND gate, the output will be 1. So this one will come as an input of the first NAND gate, and 1 and 1 you will get the 0. So you can see from the equation it's clear that the value of the q is 0 and the value of the q complement is 1. So complement of the 0 is always 1. So it is proved for this state too. So we have these two states which are easy to implement in SR latch. Now come to the third point, which is when I am giving the 1 and 1 input to the system, what will be our output? So let's say I am giving 1 in the S and 1 in the R, what will be our output? So it is difficult to say that our second input will be 0 or our second input will be 1. So we have 1 here and we have 1 here, so we have unknown two inputs. So we cannot say that the second input must be 0 or the second input must be 1. So we cannot recognize the second input. So in that case it is difficult for us to implement that SR latch. So we can see we are not getting any kind of output in that system sorry, by using the NAND gate. So if I am giving 1 as an S, what will be our output? If I am giving 1 as an R, what will be our output? Because we have no other input to the system, which is not 0 in NAND gate case. So this state 1 and 1, this S is equal to 1 and R is equal to 1, we are not getting any kind of output. So this state is known as sorry, hold state. So we can write hold state. Hold state mean, as in I have just mentioned you before, that this sequential circuit work on a pass output state. So when whatever the thing is here in the past output, you can just write that pass output. So we can see say simply that this state is known as the hold state. Hold state mean whichever the output was there before giving that input to the system, that output will be displayed. So this is known as the hold state. Hold state mean when you are giving S1 and R1, you are not getting any kind of output from the system, because you cannot say the second input will be 0 or the second input will be 1. So this state is known as the hold state of that system. So you will get the past output in your output. So this state 1 and 1, this S is equal to 1 and R is equal to 1, we are not getting any kind of output. So this state is known as sorry, hold state. So we can write hold state. Hold state mean, as in I have just mentioned you before, that this sequential circuit work on a pass output state. So when whatever the thing is here in the past output, you can just write that pass output. So we can see say simply that this state is known as the hold state. Hold state mean whichever the output was there before giving that input to the system, that output will be displayed. So this is known as the hold state. Hold state mean when you are giving S1 and R1, you are not getting any kind of output from the system, because you cannot say the second input will be 0 or the second input will be 1. So this state is known as the hold state of that system. So you will get the past output in your output. Okay, for the last input 0 and 0, I am going to give S is equal to 0 and the R is equal to 0 as my input to the SR latch by using NAND gate circuit. So you can see the input was 0 and the both inputs are 0, and by using the property of a NAND gate, If any of the input is 0, the output will be 1. So we have no concern with the second input. What will be our second input? Either the second input will be 1 or the second input will be 0. So we have no concern with the second input. So we have simply 0 and 0 as an input, which is the at least 1 0 we have for a NAND gate case. So whenever you have a 0, you will get the output 1. So this one will come as an input to the second NAND gate, and this will become 1. Okay. So what is the answer for NAND of 1 and 0? For 1 and 0 you will get 1. So you will get 1 here. So you can see that the Q value is 1 and the Q complement is also 1. This equation not satisfying the condition is not satisfying the equation, that the value of the Q is 1 and the value of the Q complement is also 1, which is the wrong, because complement is always the inverse of that value. So the 1 complement must be 0 and the 0 complement must be 1. So we have the Q value here 1 and the Q bar 1. So this is not satisfying that condition, that the Q and the Q complement. So we can just say, when we are going to give the input 0 to the S and 0 to the R, for this case we have the answer invalid state. Invalid state in SR latch, because the condition is not satisfying. Why? Because we have Q and the Q complement. So the Q complement must be 0. If we have 1 here, the complement of that value must be 0 here. So we are getting the same answer, 1 here and the 1 here, that the condition is not satisfying for our case. So we can just say that for 0 and 0, this is invalid state.